Hello friends, Mr. Burrell here. We're in our second lesson in Unit 7. Again, this is a really short unit. There's not a lot of lessons in this unit. We just had one where we talked about graphing radical equations, and we talked about what the domain and the range looked like when we were graphing radical equations. We talked about square root functions that look kind of like this. We talked about cube root functions that look kind of like this, almost like these polynomial functions turned on their sides. So now we're going to talk about solving radical equations. We talked about graphing, now we're going to talk about solving. So sometimes I teach these lessons in a different order, but this is the order I decided to teach them this time because I feel like the way that I teach this is pretty helpful. So let's go ahead and get started. By the end of this lesson, this is what I hope that you are able to do. I hope that you are able to solve radical equations. Radical meaning these equations that have these square or cube or other roots in them. And then check for extraneous solutions in radical equations. We've talked about this word before. We've talked about what an extraneous solution is, and we'll review what that is here in just a moment. So, a few things to remember about radical equations. So back in your former math experience, we've talked a little bit about this. But some things to remember as we're moving forward talking about radical equations. The square root of x can also be written as x to the power of 1/2. If I have x to the first power, x, and then the square root, I can rewrite the square root of x as x to the 1/2. Radicals and fraction exponents are very closely related. Likewise here, the cube root of x can be written as x to the 1/3 power. So a cube root function and x to the 1/3, they are representing the same thing. I can write them either way. And then something like this, the cube root of x squared, this number goes in the top, this number goes in the bottom. The cube root of x squared is x to the power of 2/3. So just some different ways to be able to write these radical expressions. If you have the radical symbol, you can also write that as a fraction exponent. So likewise, one of the other when talking about exponents, so some of the other exponent rules we learned back in like Math 2 it was something like this. X to the 1/2 power squared. When I take an exponent to the power of another exponent, I multiply those exponents together. X to the 1/2 to the second power would be x to the 1/2 times 2 power, where 1/2 times 2 is just 1. So x to the 1/2 power, when I square that, it just gives me x. X to the 1/3 power, when I cube that, or take that to the third power, 1/3 times 3 is just 1. So x to the 1/3 power to the third power is just x to the first power. Same down here, if I were to write x to the 1/2 power as the square root of x, the square root of x squared, the square root and the squared undo each other and give me x. The cube root of x cubed, the cube root and the cube cancel each other out, and I'm left with just x. Those things can be kind of handy when we're talking about some of these different types of radical equations. So just as a reminder, it might be good to refresh your brain on some of these rules. This slide can be pretty handy. Okay, so let me give you some sample equations, and let's ponder on if we remember how to solve them. So 3x plus 1 equals 2x plus 4. How would I solve this? Well, I'd need to get all my x's on the same side, so I'd need to subtract 2x on both sides, which gives me 3x minus 2x, which is x, plus 1 equals 4. And then I would need to subtract 1 on both sides, which would give me x equals 3. That would give me x equals 3. So my solution here would be x equals 3. If I plugged 3 back in for x here, just to double check, I could confirm, in fact, that that works. 3 times 3 is 9, plus 1 is 10. 2 times 3 is 6, plus, 4 is 10. So that's how I would solve an equation like that. That's a linear equation. We have a lot of experience with that. We just recently talked about rational functions. So I talked about something like this. 3x plus 1 over 5x equals 2x plus 4 over 5x. When I have a rational function like this, when they have the same denominator, as long as they have the same denominator, I can basically just ignore the denominator and solve just using the top. 3x plus 1 equals 2x plus 4, which turns into this same equation that I had up here. So I solve it the exact same way. Third option here, now we're talking about radical functions. So what if I had something like this? I have the square root of 3x plus 1 equals the square root of 2x plus 4. Well, keep in mind, if I go back to this previous slide, remember that I can undo its square root by squaring, or taking to the second power. I can get rid of that by squaring. So on this problem, if I square this side, if I multiply it by itself here, that would get rid of this square root. But if I square on one side, I have to square on the other side. So on both sides, if I get rid of the square roots, I'm left with 3x plus 1 equals 2x plus 4. So if I have a square root on both sides like that, I can basically just get rid of the square roots. I square both sides, get rid of the square roots, and again, I get this same exact equation, 3x plus 1 equals 2x plus 4, and I can solve it the same way as I did at the very beginning here, just like a linear equation. So that's one of the tips that we're going to run into in some of these problems with radical equations. Let's look at something else. How about these ones? Here I have x to the 1/2 power equals 3. So if I have x to the 1/2 power, in order to get x by itself, I don't want this exponent anymore. So if I go back here, how did I get rid of x to the 1/2 power? Well, I squared it. Just like if I had the square root of x, I get rid of the square root by squaring. I undo this exponent, I get rid of this exponent, x to the 1/2 power, by squaring it, taking it to the second power. So if I take this to the second power on this side, x to the 1/2 to the power of 2, 2 times 1/2 is 1, and I'm just left with x. But if I square the left side, I have to square the right side. 3 squared, or 3 times 3, is 9. So in this case, my answer would be x equals 9. So I squared both sides there. Now, how about something like this? This is gonna get a little bit more exciting. So I have 3v minus 9 to the 1/2 power and v minus 3. Well, I don't want this 1/2 power over here, so everything in this parentheses, if I take everything here and square it, the 1/2 power times the 2 power, those are going to go away and leave me with 3v minus 9. And on the right-hand side, if I square on the left, I have to square on the right. I have to take v minus 3 squared, which is the same as v minus 3 times v minus 3. So v minus 3 times v minus 3, I'm kind of reflecting back to what I know about multiplying polynomials. I can go ahead and use my little rainbow to distribute everything in the first parentheses into the second parentheses, which gives me v squared minus 3v minus 3v plus 9. Negative 3 and negative 3v give me negative 6v. So now this is a question on your homework. I'm not going to finish this all the way, but now I have 3v minus 9 equals v squared minus 6v plus 9. Now this is an equation that I can solve. This isn't a linear equation anymore. This is a quadratic equation. So I'm going to go ahead and subtract 3v on both sides, which would give me negative 9 equals v squared minus 9v plus 9. And I would add 9 on both sides, which would give me 0 equals v squared minus 9v plus 18. And now this is a quadratic expression that I can factor. So I could solve this either by factoring or using the quadratic formula, if you remember that from a little while ago. Or I can solve this by factoring. So I turned this radical expression, the one with the fraction exponents, into a quadratic expression that I do indeed know how to solve. Okay? So I'm going to leave you to be able to solve that. Keep in mind I'm trying to find two numbers that multiply to make 18 and add up to negative 9. You can finish that on your own. So moving on, a lot of the problems that we're going to be doing are going to look similar to those types of problems. I'm going to be solving by taking care of the square root, getting rid of the square root, getting rid of the fraction exponents, and then whatever is left I'm going to solve, whether that's a linear equation or a quadratic equation or something like that. So the next thing we need to discuss is what is an extraneous solution. So if you remember back to when we talked about like fractions, when we were talking about rational functions, an extraneous solution was any solution that actually makes me divide by 0. So like in this example, if I solved this is not super relevant, but if I solved a rational equation and I got a solution of x equals 2, for example, if I went back and double checked in this original equation and plugged 2 in for x, I recognize that when I do that, I get 5 over 0, which I can't do, which is undefined. So x equals 2 is what we would call an extraneous solution, because it doesn't actually satisfy the original equation when I plug it back in. It doesn't work. It makes me divide by 0. So, same thing applies here. An extraneous solution is a solution that when you plug it back into the original equation, it is invalid. So let's take a look at our square root function just as an example. So if I look at my square root function, notice like I start at 0. My domain of this function is from 0 to infinity, right? My domain we just talked about in the previous video is from 0 to infinity. The range is also from 0 to infinity in this case. So note that the range values are restricted. The range values, the possible outcome values of this function are restricted. I'm not going to be able to get every single possible output value. In this case, I only get from like 0 to infinity. In other words, the outcomes of a square root need to be positive. If I had outcomes of a square root that were negative, it would look like this, and that's not a function. That's not what our square root function does. I'm only able to have these positive results. That's what makes this a function. So for example, the square root of 4 on my graph here is equal to 2. So if I look on my function at x equals 4, the square root of 4 is 2. See that? But on my graph, if I look in the negative direction, the square root of 4, I don't have a negative 2 option. That doesn't work on my graph, so that would be an extraneous solution. So, let's take a look at what this is going to look like. So for example, this is a question on your homework. I have 2 minus n to the 1/2 power equals n. So I'd solve this like I did some of those other ones. I get rid of this 1/2 power by squaring this side, and if I square the left side, I have to square the right side. These cancel out, and I'm left with 2 minus n equals n squared. This is going to be a quadratic function, so I'll go ahead and add n on both sides, and I'll subtract 2 on both sides, which leaves me with n squared plus n minus 2 equals 0. Okay, well when I factor this, I need to find two numbers that multiply to make a negative 2 and add up to 1, which would be 2 times negative 1, because 2 times negative 1 is negative 2, 2 plus negative 1 is 1. So when I put this into their individual factors here, I get n plus 2, n minus 1. When I set each of those equal to 0, if I set each of these factors equal to 0, because when they're being multiplied together and set equal to 0, I set those equal to 0, and I end up with the solutions of n equals negative 2 and 1. Well, that's all fine and dandy. Those might be my solutions, negative 2 and 1. But let's just double check that when I put these back in here, that's actually going to work. So let's put these values in. So if n is equal to negative 2, that would mean in my parentheses I have 2 minus negative 2 to the 1/2 power equals negative 2. And then down here I'd have, if n equals 1, then I'd have 2 minus 1 to the 1/2 power equals 1. Okay, well, 2 minus negative 2, that's 2 plus 2, which is 4. So I have 4 to the 1/2 power equals negative 2. Remember, to the 1/2 power is the same as a square root. And the square root of 4, let me go back here. In our function, the square root of 4 is a positive 2, not a negative 2. See that? The square root of 4 is a positive 2, not a negative 2. So coming back here, since when I plugged everything back in, I got the square root of 4 being equal to a negative number, in my function, that's not going to work. So negative 2 is going to be an extraneous solution. Negative 2 is not going to work. Let's take a look at n equals 1. 2 minus 1 is 1. 1 to the 1/2 power equals 1. Well, to the 1/2 power, that's the same as writing the square root. The square root of 1 is equal to positive 1. That works. That's okay. I don't have a negative over here. This is still positive, so that's going to be fine. So my solutions, since negative 2 was an extraneous solution, my only solution is n equals positive 1. Okay, that was a question off your homework. Let's look at a couple other examples here. So I have 4 examples here that we'll go over either 3 or 4 of them. So let's look at this first one I have. The first problem is the square root of x minus 3 equals 4. Okay, how do I get rid of the square root? Well, I undo the square root with square. If I square a square root, the square root goes away. The square root of x minus 3 squared, that's just going to go away. If I square on the left-hand side, I have to square on the right-hand side. So the square root and the squared, the exponent of 2 here, cancel out, and I'm left with x minus 3 equals, and then 4 squared is equal to 16. Well, this one's actually super nice. This is going to work out super well. X minus 3 equals 16. I'm going to go ahead and add 3 on both sides. Negative 3 plus 3 is 0, and I'm left with x equals 19. That's my answer. That's it. Let's double check if I were to plug 19 back in for x here. 19 minus 3, square root of 19 minus 3 equals 4. Well, the square root of 19 minus 3, that's the square root of 16. The square root of 16 is indeed a positive 4. So I've double checked. X equals 19 is my solution. Okay, let's look at number 2. I have the square root of 13 minus m equals m minus 1. Or the square root of m minus 1, sorry. So now I have a square root on both sides. How do I undo a square root again? With a squared. I'm going to square both sides. I'm going to take both sides to an exponent of 2, because that will get rid of the square root on both sides, leaving me just with 13 minus m equals m minus 1. Again, now this is just a linear function. I can get all my m's on one side, all my numbers on the other side. I'm going to go ahead and add m on both sides. I have a minus m, so I undo that with a plus m. I'm left with 13 equals m plus m is 2m minus 1. Then we'll go ahead and add 1 on both sides, because negative 1 plus 1 is 0, and I'll be left with 2m equals 14. And then since I have 2 times m, I'm going to go ahead and divide by 2 on both sides. 2 divided by 2 cancels out, and I'm left with m equals 7. So my answer, whichever way you want to write it, is m equals 7. So let's go ahead and plug that back into my original equation. Just double check that that's going to work. If I take the square root of 13 minus 7 equals the square root of 7 minus 1, that's the square root of 6 equals the square root of 6, that's going to work out just fine. It's going to be good. So my answer is 7. Okay, let's look at a couple other examples. So here, these will get a little bit more exciting. So here I have p minus 4 equals 6p minus 32 to the 1/2 power. Okay, don't get thrown off by this fraction exponent. Remember, that 1/2 is really the same as writing a square root here. So, how do I undo something to the 1/2 power? I take it to the second power. I square it. So I'm going to square both sides. Okay, so those are going to cancel out, and I'll be left with 6p minus 32. On this side, p minus 4 squared, that's p minus 4 times p minus 4. A lot of people have the inkling, have the tendency to just say, oh, p minus 4 squared, that's p squared minus 16 or plus 16 or something like that. But remember, when you square something like this, p minus 4 squared is p minus 4 times p minus 4. I'm going to go ahead and do my little rainbow to multiply these together. P times p is p squared, and then minus 4p plus 16 equals 6p minus 32. Well, I can combine these together. I get p squared minus 8p plus 16 equals 6p minus 32. Notice I have a p squared here, so this is going to be a quadratic function. I'm going to need to solve this like a quadratic. So I'm going to go ahead and get everything on the same side. I'm going to subtract 6p on both sides. This goes away. That's p squared minus 14p plus 16 equals negative 32. I'm going to go ahead and add 32 on both sides. Negative 32 plus 32 is 0, and I'm left with p squared minus 14p plus 48, or 40, is that 44? 44? Oh, this is supposed to be a 16. My apologies. 16 plus 32 is 48 equals 0. Thank you, Mr. Burrell, for catching my own mistake. So I have p squared minus 14p plus 48. Okay, in order to solve this, I'm going to need to factor or use the quadratic formula. I think factoring would probably be the easiest in this case. So I multiply the first and the last numbers, which is 48. I'm going to find two numbers that multiply to make 48 and add up to negative 14. You can pause this and find those numbers. The numbers, I'm going to save us some time in this video here. Negative 6 times negative 8 is a positive 48. Negative 6 plus negative 8 is negative 14. So in my parentheses here, I have p minus 6 over 1, p minus 8 over 1, because a is equal to 1 here, but in this case, that doesn't even matter. So I have p minus 6 times p minus 8 equals 0. So I'll set both of those equal to 0, p minus 6 equal to 0, p minus 8 is equal to 0, add 6 on both sides, add 8 on both sides, and I get p equals 6 and 8. P equals 6 and 8. Those are my two solutions. So let me come back here. I'm going to clear some space for a second. Pardon me, I hope you have that work written down. I'm going to clear some space for a moment. I need to plug those back in and make sure that they're actually going to work. So when p is equal to 6, let's see what that gives me. That's going to give me 6 minus 4 equals 6p, so 6 times 6 minus 32 to the 1/2 power. So 6 minus 4, that's 2. 6 times 6 is 36. Minus 32 is 4. So I have 4 to the 1/2 power. Or remember, taking something to the 1/2 power is the same as square rooting. So 2, positive 2, is indeed equal to the square root of 4. So 6, that works. Let's check 8. So if I put 8 in for p, I get 8 minus 4 equals 6 times 8 minus 32 to the 1/2 power. 8 minus 4 is 4. 6 times 8 is 48. Minus 32, well, that's going to be 16 to the 1/2 power. Remember, taking something to the power of 1/2 is the same as square rooting it. And the square root of 16 is indeed a positive 4. So both of those are good. 6 and 8 are both valid answers. Okay, we're feeling good. We're feeling confident. So in this last one, let's go ahead and see here. I have 5 minus the cube root of x minus 4 equals 2. So before I can start cubing or squaring things on both sides, I need to have this all by itself. So let's go ahead. What I'm going to do is I'm going to go ahead and subtract 5 on both sides because I don't want this 5 here. I have negative cube root x minus 4 equals negative 3. And I don't want this negative over here either, because I want this cube root to be all by itself. So I'm going to multiply both sides by negative 1. Okay? So that's going to give me the cube root of x minus 4 equals positive 3. Well, how do I get rid of a cube root? I'm going to cube each side, because the cube root and the cube will cancel out, which leaves me with x minus 4 equals 27. And then I'm going to go ahead and add 4. 3 cubed is 27. I'm going to add 4 on both sides, which gives me x equals 31. You can double check that, plug that back in to double check that that actually works and is not an extraneous solution. That's all I've got for you. That is everything. That is everything in this lesson that we need to know. Everything you could possibly need to know about radical functions. Remember, when we're solving radical functions, we're talking about square roots, cube roots, to the 1/2 power, to the 1/3 power. Those are the ones we see the most often. So hopefully now you're able to solve radical equations using some of those tools that we've discussed, and then check for extraneous solutions, or those solutions that when you plug them in actually don't work. Hopefully you can check for those extraneous solutions in these radical equations. So that's everything I've got for you. I hope that was helpful. Please be sure to reach out to me if you have any questions whatsoever. I hope that you enjoyed that as much as I did.